So this time, let's learn how to balance redox reactions. In the previous video, we have learned how to assign oxidation numbers to each element in a compound or in an ion. And we have learned the difference between a reduction and an oxidation reaction and what redox reactions are. So we learn now again how to balance redox reactions. So there are a few things that we must remember in balancing redox reactions. Now, whenever we balance a chemical equation, diba, when you recall, you learned how to balance chemical equations in high school. And diba, in a chemical equation, you have a reactant. So the substances present before a chemical reaction are called the reactants. They're separated by an arrow, and then the substances present after a chemical reaction are called the products. And in balancing chemical equations, ang atong hinumduman ato is that ang law of conservation of mass is observed, di ba? So, unsaon na pagkaibaw nga na-conserve ang mass or matter? That the amount of each element must be the same on both sides of the equation. The number of atoms of each element present on the reactant side must be equal to the number of atoms of the same element on the products nga side. That's why kung mag-balance ta, di ba, magbutang tag number before the compound. So ang ato radyong himuunan na nag-balance na to sa equation is that we put a number, a coefficient before the substance, and remember that we do not put a number, we do not change the number nga subscripts. Fixed na siya. So, inig-balance na to sa chemical equation, ang ato ragyong hilabtan, kaya ang katong coefficient. So, di ba mo na itong tanawon? And that still applies in balancing redox reactions. So, we must remember that atoms are neither created nor destroyed in a chemical reaction. That's why the number of atoms of each element, again, present on the reactant and product sides must be equal. Now, that's for diba? Right, balancing an ordinary chemical equation. But if the equation represents a redox reaction, aside from looking at the number of atoms of each element on the reactant and the product side, another thing that we must look at is the number of electrons. So we must be looking at the charge sa reactant o charge sa product. Okay? An additional requirement in balancing redox reactions is that the gains and losses of electrons must be balanced. So, how do we check? The number of electrons on both sides of the equation must equal. In other words, kung pilay charge sa reactant, total charge sa reactant nga side, mao sad nay total charge sa product nga side. And the same thing with atoms, we must remember that if a substance loses an electron, during a reaction, another substance must gain the same number of electrons. So just like atoms, electrons also are neither created nor destroyed in a chemical reaction because they are just transferred to another substance. So in balancing redox reactions, we look at the number of atoms and we look at the electrons on both the reactant and the products nga side. Now, how do we balance redox reactions? So the method used in balancing redox reactions is called the half reaction method. Now, why is it called the half reaction method? Or another name for this is the ion electron method. Again, it's called, the method for balancing redox reactions is called the ion electron method or the half reaction method. It's called the half reaction method because, so this is it. In this method, the equation is separated into two half equations. Buwagon siya into two half equations. Kaya diba kung redox reaction, it's called redox because there is reduction and there is oxidation at the same time. Simultaneous sila. So, it's separated into two half equations. One equation represents the oxidation nga half reaction and the other equation represents the reduction half reaction. And combined together, muna siyang redox nga reaction. Now, so ikahuman og separate sa two half equations, i-balance na siya. So, how is it balanced? So, dili lang siya simple nga adjust og kanang coefficients. It's by adjusting the coefficients, but aside from that, butangan og water, butangan og hydrogen ion, dugangan og hydrogen ion, and electrons. in this order depending on the condition of the reaction. So it isn't just adjusting the coefficients, it may sometimes involve the addition of water or hydrogen ion or the hydroxide ion and electrons. So in this order, meaning kinalasan ang number of electrons. And ningon siya dire depending on the condition of the reaction. So ang pasabot niya is kung unsay condition sa solution or unsa ang solution is either pwede siya neutral, pwede siya acidic, o pwede siya basic. So tan-awonon ni siya inig-solve sa equation. So neutral, acidic, or basic. Okay? Now, specifically, unsa man if we really write kung unsa gi step by step nga procedure in balancing or in using the half reaction method in balancing the redox reaction. So mo ni siya. So these are the steps in balancing. Now, the first step is very crucial because kung sayop ta sa first step, sayop tanan class. It's very crucial. That's why we discussed about this in the previous video nga unsa man ni siya that we assign oxidation numbers to all atoms on both sides of the equation. Now, why do we assign oxidation numbers? Because it is through the oxidation numbers that we are able to determine kung unsa nga substance ang ni-undergo og oxidation and reduction. Now, I said that this is crucial nga part because kung sayop ta, basig mabali na to. Basin ang dapat ni undergo oxidation kay igtanaw na to kay nasayop man ta sa atong pag-assign la ni undergo na hinuon siya reduction, no? So we have to be very careful because this will affect the entire solution. So after we assign oxidation numbers and after we have determined which substance ang ni-undergo oxidation and reduction, so the second step is to write the two unbalanced half equations. So naatay oxidation nga half reaction ug naatay reduction nga half reaction. So buwagon siyang duha, no? After which, the third step is to insert coefficients to make the number of all atoms of all elements equal on both sides of the equation. So balancing, pareha sa balancing pag high school, no? You insert coefficients. Pero in this part here, wala pay labot, dili pa nato i-balance og apil si oxygen ug hydrogen. All elements except oxygen and hydrogen. Because in the fourth step, i-balance na si oxygen. So, i-balance oxygen, and how do we balance oxygen? By adding water. So, depende kung asa siya nga side, nagkulang og oxygen. So, pananglitan sa reactant side, na isa ka oxygen, unya sa product side, kay walay oxygen. So, mudugang kag, isa ka water sa product side para equal na, nanay oxygen on both sides, no? So, ato dyang hinumduman nga sa water, kay naay isa ka oxygen. So, kung pilay kulang nga oxygen, that's also the number of water molecules that you're going to add in the equation. So, either left or right, depende kung asa siya needed. So, all elements except oxygen and hydrogen, and then balance oxygen by adding water. Next is we balance hydrogen by adding H+ ion. So, we balance hydrogen by adding the appropriate number of hydronium ions to the opposite side of the equation where the water was added. So, kung sa product nga side ni add si water, so of course, adto ka sa reactant side mo add ni hydrogen. Kung sa reactant side gi-add si water, then you're going to add hydrogen on the product nga side. Basta lang, kay dapat ma-equal ang hydrogen on both sides of the equation. Next is to balance the charge on each side by inserting electrons to the more positive side. Again, we insert electrons. So, depende kung pilay kulang niya nga kuan, basta kay we add electrons to the more positive nga side. Depende kung pilay discrepancy. Basta kung pilay charge, dapat at the end of this step, kung pilay charge nga naa sa left side, mo side charge, total charge nga naa sa right side sa equation. And then step number 7 is to make the number of electrons on both half reactions equal. So, pananglitan sa reduction half reaction, naaray isa ka electron. Unya, sa oxidation kay naay duha ka electron. So, you have to make them equal. So, kinahanglan i-multiply ang isa ka equation by 2. So, it's not 2 all the time. Depende siya kung pilay kulang. So, if they are not equal, multiply the two half equations by the least common multiple of the number of electrons on both sides of the equation. Basta ang target ani, kinahanglan, kung pilay electrons nga naa sa reduction half reaction, mo sa same number of electrons nga naa sa oxidation half reaction. Dapat equal ang electrons nga naa sa duha ka half reactions. Next is na-equal na ang number of electrons. Next is to add the two half equations. So, the purpose of number 7, nganong dapat equal ang electrons sa both oxidation and reduction half reactions kay i-add man na siya duha, niya dapat makancel ang electrons. Na ato hinumduman class nga kung oxidation gani, okay? Diba sa oxidation kay mulus man na siya og electrons are lost. So, add electrons on the product nga side. Product side gina siya. So, kung masayop ka, pananglitan, oxidation imong gi-assign, unya paghuman ng electron kay imong gi-add sa reactant. So, there must be something wrong with the equation. So, dapat mo-follow gina siya pirmi. So, kay mugain man ni siya og electrons sa reduction, electrons are gained. Asa man dapitan na to i-add ang electrons. So, add electrons on the reactant side. Asa ng reactant side, kanang naa sa left side sa equation. Okay? So, if the number of electrons on both half reactions are already equal, so, diba, kay naaman siya sa product nga side ang isa, unya naa sa reactant nga side ang isa, so, inig-add, makancel ra na siya. So, add the two half equations, canceling electrons, and then canceling also some common terms. But if the equation being balanced is in a basic solution, so dapat, kung neutral, walay H plus or OH nga ions. If it is acidic, so dapat ang mahabilin nga ion is hydrogen. If it is basic, dapat ang mahabilin nga ion is OH. Okay? So hydrogen raman to atong gi-add ganiha, but if it is a basic solution, atong ilisan si hydrogen o OH. So add the appropriate number of hydroxide ions on both sides of the equation, and on the side with the remaining H plus ions combine to form H2O molecule. So pananglitan na kay H plus OH negative. So dapat mo form na siya H2O. Okay? H plus it's either kani imong i-add, depende siya. Depende pod sa coefficients kung pilay gusto nimo i-cancel, and then pwede sad nga H2O ma-decompose siya into hydrogen, hydronium, and hydroxide nga ion. Okay? So those are really the step-by-step nga procedure in balancing redox reactions using the half reaction method.